Uh, about your current research, I don't know if you know if does it exist the contrary? I mean, from an image, predict the audio. I don't know. I am imagining like a concert without audio, but you can predict like what is the song that they are playing, or I don't know.
Yeah, there's a lot of ongoing work in that, like right now, actually. So there's kind of a few different, I guess, work streams with that. Like one kind of angle is people trying to do audio generation itself from video data. I haven't kind of personally worked in that space, but it's definitely an active area of research with is like actually kind of recreating the audio signal itself from the image. And kind of I guess another angle you could take is like, yeah, I guess something like we're doing with where you're not necessarily kind of generating the signal, but maybe you're just kind of predicting like a label for the scene or something like that, which definitely has been worked on as well. I don't know, Aron's working in the multimodal space right now too.
Okay, perfect.
Yeah.
Yeah, so one cool example that people do is, so I'm gonna share my screen, but basically you train a model to locate objects in a video, and by that I mean like that you train the model to identify in a video where is the object that is making the sound. And after you have done that with some success, you can do the inverse, where, for example, you can show a picture. So this is a picture of this guy who it's clearly a picture of someone playing guitar, right? And then out of a database, a model will identify, the model tells you these are the top 5 things that I think are related to the picture you sent me. But here on the left, everything is picture to picture, okay? Now, here in the center, this is sound. So when you see the speaker here is only sound. They mean they're showing the sound, and this is what you get. So you get, from the sound, you get these images, okay? Now, if you show the sound and you tell the model, okay, sound to sound, like here's sound, tell me which sounds sound similar, or which sounds you retrieve or associate similar. This is what you get. So it's examples of people playing guitar. And here is the opposite. Here's an image. What is the sound that is associated with this image? And these are the sounds you get. So as you see, like when you go from image to image, the top one is the image that corresponds. When you go from sound to sound, the top one is the sound that corresponds. But when you go cross-model from sound to image or from image to sound, you get things that are highly related, but it's not a perfect match because the model is kind of like imagining what sounds match what you are using the query.
I thought this paper I thought did a pretty good job of representing something that's very hard to represent on paper with the sound icon here.
Yeah. Yeah. So yeah, it's very, everybody's trying to do this. Yes. Everybody right now is trying to, like, to some extent, myself included, with little success, but I'm trying. Any other questions?
Do you have the video label, or you're using like a unsupervised approach to do the
the model? That's a good question. Yeah, so we have the kind of the vehicle data set. We did label ourselves actually, which is a very painstaking process because in that sample image I showed, there was like 10 vehicles in one frame. So we have kind of bounding box annotations for the video data, where we actually had human annotators go through and draw boxes around the videos frame by frame. And then we also have annotations on the audio side where we had people listening to just the audio without seeing the scene and kind of saying, the audio annotations look something like from 0 to 2 seconds car sound. So with the model that we're working with now, the input is the audio data, and the associated labels are kind of parsed from the bounding boxes. So we pair kind of like, at frame 1, we have a car with an X coordinate of 10 or something like that. And that's what we're trying to predict essentially.
And last question, because we're gonna let Julia go and continue with everything she has to do.
No, it's okay.
Michelle.
Yeah, hello, Julia. Awesome paper, and the talking. I really enjoyed it. Well, my question is kind of related to the last part of we were like discussing about the audio related sound stuff, melodies. I mean, everybody could answer if anybody knows. I'm open that, but it's basically if anybody knows if somebody is working on a model that's trying to do like a correlation like with notation. I'm more like interested, especially like in piano rolls, like what happens if we have the piano rolls like in Do, like start to thinking of piano rolls in those as a type of notation, so that I think at least get like the pitch correlation, or maybe, because I mean timbres will be pretty crazy to get it, but maybe with sound waves, or maybe somebody's doing that with with normal scores, that at least will be the first step to get that idea of getting something. Because I don't know, sometimes, and I've talked this with other people that make music on the DAWs, that make you get like to see the DAW somebody else, or like in a video on YouTube, and you kind of know what's gonna sound. So it's kind of that notation type that normal traditional notation has. So maybe that could expand it a little bit to get like sheet music out of pure like screenshots from DAW. I don't know. I'm expanding a thought that I have.
So you're saying if there's research on using piano rolls to generate audio, for example, and then you're relating that to like a digital audio workstation where it kind of looks like a piano roll. You are synthesizing sounds with MIDI or stuff like that.
Yeah. So yeah, to get like sound out of that. I mean,
do that? Like, is that anybody in the Pardo lab doing that kind of stuff?
Not that I know of. That's really interesting though. And it feels like kind of it feels almost like a natural progression just from even using like a spectrogram representation. Like you could just treat it as image data, right?
Yeah. One of my fellow students in my PhD was doing piano transcription from recordings, and she focused on Chopin mazurkas or something like that. And the problem was so complex that she had to narrow it down to like one composer, one pianist, one set of pieces, because if you try to do it with a big data approach, it was just not happening. Actually, Jose knows her, Kitty.
Daisy, I think, or
Kitty, Kitty.
Kitty. Yeah, Kitty. Yeah.
Do you know her, Julia? Kitty? One of the no. Okay. You smiled, so I thought maybe you know her, but she's awesome. Anyways.
Cool.
All right. Well, everybody, please join me thanking Julia, congratulating her for all the awesome work she's doing, and wishing her luck with all the many things she has on her plate and she's doing in an awesome way. So please give her a hand. And Julia, we're gonna stay here. This class lasts longer, so you're free to go. And thank you very much for staying here with us and sharing your.
Thank you for having me. It was a great discussion, and I really, really appreciated the really thoughtful questions on the paper. So thanks for having me. And Iran can share my email or any contact information if you're curious about using the data set or just more questions on any of these things. So thanks. Have a good rest of your day, everyone.
Thank you. Bye.
Thank you. Bye.